Let's do a quick proof here. That's asking me to do a two-column proof, statements and reasons. So if I'm looking at the first thing that I want to say, we usually state what's given. Well, G, H, L, M is parallelogram. That's given. We also have something else that's given. Angle L is equal to angle, or congruent to, I should say, J, M, G. That's also given. Now the last piece here, we see that GJM is isosceles, is what we eventually want to get here. So how could I make this an isosceles triangle? That's this triangle right here. Well, I know that if I have two base angles that are congruent, so in other words, if this angle right here was somehow congruent to GJ or JMG, that would be helpful. Hang on a second. I know that L and G are congruent. Let's go ahead and state that. Angle L is congruent to angle G. How do we know that? Opposite angles are congruent. Opposite angles are congruent within a parallelogram. So then the last one, it's actually very easy. Well, actually two steps here. We know that JGM is congruent to angle JMG. Why? Transitive property of congruency. So then the last statement, we're going to say that triangle GJM is isosceles. Why? Because it has two congruent angles. I know there's a theorem out there, but the general idea is that it has two congruent angles. That makes it isosceles. That's all you really need. Okay, these last little examples here, the little pieces we're pulling out from 6.3, we're not doing the whole section, but just a little bit of reasoning is taking place. So looking at this is, determine if the quadrilateral must be a parallelogram, justify your answer. This one is no. It is no. Why? Well, it has one pair of opposite angles, but we need to know something about the other pair. And even though these two sides are congruent, they need to be opposite. Determine if the quadrilateral must be a parallelogram. Well, if I look at this one, I see one diagonal bisected, I see the other diagonal bisected. This one is actually a rectangle, but even not considering that, I'm going to say yes, it's a parallelogram. Why? Because the diagonals bisect each other. This next one's a little bit harder. If you notice, we have this side and this angle representing our congruent relationships. If I were to mark a third side here, the shared side, that would tell me that these have a side-side angle relationship. Well, you know, looking at it, it seems like it would be congruent, but it's really difficult to tell, because even though it's side-side angle, it's hard to see if this line could be over here and have a different type of relationship. Because when we have side-side angle, it's kind of that ambiguous case where it depends on where this other swing arm is and how long it is compared to the other side. It looks longer. Visually, it looks longer. Visually, it looks like a parallelogram, but I don't really have the evidence to confirm that. Well, you guys, that's it for Chapter 6 with parallelograms. Just a quick couple of ideas and review concepts. Make sure that you're keeping up on all your other stuff. Again, this was parallelograms.